Scientists claim that our planet is 4.6 billion years old. What evidence is there that supports this claim? What do scientists use to support their argument for the billions of years that our planet has existed? In places like the Grand Canyon, rock has a story to tell. Each layer exposed here is a chapter of Earth's history. We just need to understand how to read it. An early naturalist, Charles Lyell, developed the idea that geologic processes are consistent over time. What we see happening today happened the same way in the past. Observing the slow changes in mountains due to weathering and erosion, Lyell reasoned that vast amounts of time would be needed to reduce towering mountain ranges into low hills. Widespread adoption of this idea limited the acceptance of catastrophism, or rapid changes in landforms due to eruptions, floods, etc. Both uniformitarianism and catastrophism play a role in shaping the Earth. Some atoms are unstable. They will spontaneously change, often by breaking down into smaller pieces. A form of uranium with atoms having an atomic mass of 238 will ultimately decay into lead. It takes 4.5 billion years for half of a sample of uranium-238 to decay into lead. This time, called a half-life, is different for each type of radioactive element. Knowing the half-life of elements is useful for determining how old things are. If you compare the amount of a radioactive element to the amount of its stable decay product, you can estimate the age of a rock. In the graph shown here, you can use the percent of material curves to determine the half-life of this element. When enough time has passed for there to be equal percentages of radioactive element and stable decay product, you have found the half-life. In this case, it is 5,000 years. Uranium and lead both are present in igneous rock in small amounts. We can measure the relative amount of each in a newly formed rock. In a much older rock, the proportion of uranium to lead will be different, due to the uranium atoms decaying and becoming lead atoms. Scientists can interpret these ratios between uranium and lead, and knowing the half-life of uranium-238, they can estimate the approximate age of the rock. Use radioactive elements and their decay, or daughter, products to establish the age of rock is called radiometric dating. Due to their half-lives, uranium, lead and potassium-argon dating are the common methods used by geologists. Much of Earth's oldest rock is no longer here. It has weathered away, been carried back into the mantle by plate tectonics, or buried under much younger rock. Some of the oldest rock in North America is in Canada. It's only around 4 billion years old. Knowing Earth is older than this is confirmed by dating meteorites and moon rocks. The oldest rocks on Earth are the Nuvvuagittuq Greenstone Belt in northern Canada. They are 4.28 billion years old. There will be assignments for you to complete about radiometric dating and half-life on Google Classroom. The Kurils and Kamchatka image is a plot of earthquake foci along a subduction zone in the Pacific. Plate tectonics, subduction of tectonic plates back into the mantle and creation of new crust at spreading centers, weathering, and volcanic activity all act to remove and/or alter the oldest rock on Earth. Old crust is recycled by being carried back down into the mantle. This process occurs at some convergent plate boundaries and is called subduction. Where oceanic continental convergence occurs, trenches form offshore and volcanic mountain ranges, like at the Pacific Northwest, form on the edge of the continental plate. There was a period of time when all of the largest impact basins and craters on the terrestrial planets and our Moon formed. It is called the Late Heavy Bombardment. Late, in terms of the process of formation of the planets, and heavy, in terms of the sheer quantity of objects crashing down. It was caused by the gas giants moving to their current stable orbits. Unlike radiometric dating that assigns a chronological age to rock, relative dating just compares when something formed to when the things around it formed. In the image shown, a series of impacts created overlapping craters. The most recent impact formed the crater on the top of the rest. The principle of original horizontality states that most sedimentary layers of rock are deposited in a horizontal position. Whether wind-blown or water-deposited, sediments settle out into flat horizontal layers due to gravity. Sediments are deposited in layers. The bottommost layer was deposited first, and thus is oldest. When the sediments are converted into rock, this sequence is preserved. In this image, the sediments were deposited and turned to stone. Stress was put on the rock and it broke, forming faults. The rock moved along the faults. This happened after the rock formed, so the faults are younger than the rock. Complete the assignment about relative dating you will find on Google Classroom.